Alright, so this is PyCAD, and you'll see how it works right now. Alright, so the way that we run this project, the only packages you need are Pygame. The rest is just NumPy. Just main.py, and then here it is. Right-click to make a new cube, or wireframe, I guess, and then we're going to press T. You see in the terminal it shows that translation is on, so we're going to grab the edge or the node. The vertices doesn't really matter too much. Then we can kind of move it around. Then if we turn translation off and then rotation on, and then if we do it about the x-axis, we can grab one of these edges and kind of rotate it about the x-axis, or the x-axis is kind of like this way. Then we're going to do the y-axis, which is like this. Do it both ways. Then z-axis, which is kind of a bit weird to do this just because of the hit detection, but yeah, and then we can put as many wireframes as we want, and we can each do each thing independently. Okay, so PyCAD is meant to be a simple CAD software which is meant to manipulate cubes in a 2D environment. And so the way that it works is essentially there's a main problem is that we need to do 3D objects in a 2D space, which is pretty challenging, but we'll make it work. So essentially the first part is storing the data, which is very important. So what we're going to do is we're going to use NumPy arrays and store them in wireframe classes so that they can be used later. So the edges represent these lines here, which are stored as vectors in R3. And then these nodes are essentially just these vertices right here, which are also stored in R3. So next part is creating the cube, which is done via right-clicking in the actual application. So we're going to use the random library to essentially generate random points, which gives you random cubes, which follow this pattern. Next part is projecting this cube to the screen. So this is linear algebra. So what we're going to do is we're going to use this transformation matrix, not directly, but a similar idea, where essentially we keep the x and y components of the vector, and then we get rid of the z component, which is quite convenient for us. So this is shown where this is a snippet of the code, where essentially node 1 is the x coordinate and node 2 is the y coordinate, and these are drawn on the screen. And then next is highlighting the edges, which essentially is when the mouse is touching an edge or a vertice, then you can click and drag it and do whatever rotation, translation, or scaling that you want to do. So essentially it's an application of closest point of a line, which is some more linear algebra stuff, so I won't go into that. And then so next part is highlighting the edge, which is done by determining when the mouse is closest to what edge. So this is, the threshold represents the node radius. So essentially if it's within that distance, then it'll highlight the edge and it'll return what edge it is and what its ID is, so it can be identified. So next is cube transformations, which you saw there's a bunch of them in the video, in the demonstration. So again, more linear algebra. So essentially first one is translation, which you saw is when you could essentially grab the cube and move it around in planar motion. So essentially it's just, you have the axis and it changes the coordinate on that axis by a factor of d, where d is the mouse position, how much the mouse moves, I guess I should say. So next is scaling. So scaling is simple. It's just, multiplying by or adding a multiple of some factor, which is s, which is also defined by the mouse position. And then next part is center of an object. This isn't a transformation, but this is important to know how it works. So essentially it takes the mean or the average of each component, which if you do that, it'll give you the very center of the cube once you get all of them when it's returned as a vector in R3, or a point, I guess. And then next is rotation. So this one's the most tricky because it involves the most linear algebra. So here we have rotating about the x-axis. So essentially it uses this transformation matrix, not directly as you can see, but it uses it. So this is just an application of that. And then, yeah, so essentially that's how that works. After we do all of that basics down, we can essentially put it into Pygame and do some mess around with it just to get it to work. And yeah, that's how it works. Thank you for your time.